Okay, so we are moving on to section 2.3, still talking about quantitative data, that data with numbers, but we're going to talk about some other ways to graph this data, some really famous ways. So the first one is a stem and leaf plot, and the stem is typically the leftmost digit, and the leaf is the rightmost digit. Now, the leaf always must be one digit, whereas the stems could be multi-digit. So what I'm talking about here is I'm talking about in the number 16.3. Here in a minute we're going to do a stem and leaf diagram, and we're going to call in 16.3, we're going to call 16 the stem, and we're going to call 0.3 the leaf. But it doesn't have to be a decimal. It could even be something like 123, in which case 12 would be the stem and 3 would be the leaf. It doesn't really matter how big or how small. You could even make it 0.13, in which case 0.1 is the stem and the leaf is, I don't know why I made all my leaves 3, but I did. Anyway, it just matters that you take that last digit and make it the leaf, and everything to the left is the stem. Okay, so here we have data below, and it's about people in poverty by state. And then you're going to draw a stem and leaf plot. So it's a percentage of the people in poverty by state using 2-year averages. And so what I have here for us is we're going to put our stems. You always put your stems on the left and your leaves on the right. Leaves, not leaves. And so your first step in this scenario is decide what is your stem and what is your leaf. It looks like all of these numbers are all to one decimal place. They're all to the tenths. So it looks like our 10th place needs to be our leaf, and our whole number is our stem. So we're going to say in 10.7, the whole number stem and the tenths place is our leaf. Okay. The next thing we need to do, now that we know what our stem and leaves are, is we need to write all the stems in increasing order. So let's see if we can determine our max and our min. So I'm seeing 9.1. Is there anything? Here's a 7.3. Is there anything lower than 7.3? I don't think so. So we're going to make this our minimum. And the maximum on our stem and leaf, there's a 19.7. I think that's our max. So we're going to make this range from 7 to 19. So we're not going to skip any numbers. We're just going to start at 7, 8, 9, 10. Sometimes people will start lower than 7 just to show a little bit more. You know what? I'm going to have to write these smaller. 7, 8, 18. Can I squeeze it in? 19. There we go. Okay, so now that we have all of our stems listed, now we're going to go back and we're going to put all of our leaves. So what you're going to do is you're going to look for all the numbers that start with 7. So we have 7.3, 7.8, and I think that's it. So you'll write the leaves over here, and here's the kind of strange part. You're going to list 3 to represent 7.3, and then you're going to go ahead and list the 8 without listing the 7 again. And so this represents 7.3 and 7.8 are 2 separate percentages that we have. Okay, and then you're going to go through and do this for all of them. So next you'll do 8. So I'm looking for any numbers that start with an 8. And I don't think there are any, so we'll just skip that. We won't write anything right here. We'll just leave that blank. Okay, now we're looking for 9s. So 9.2, 9.9, 9.1, 9.6, 9.8, 9.3, and 9.8. And so we'll come over here to our stem and leaf and we'll list those. So the first one, I believe, was 9.1. There was a 9.2. What else was there over here? 9.1, 9.2, 9.9. So I'm just listing all the tenths place. I believe there was a 1 and a 6. Oh, do I have 9.1 listed twice? I think I do. My bad. So there was a 6, an 8, a 3, and an 8. 8, 3, 8. You do have to list the 8 for both times it was listed. Okay, I think that's all of them. Alright, so then you're going to go through and look for all the 10s. So, there's 1, there's 1. There's 1. There's 1. So I think there's one more missing somewhere. Oh, here it is, 10.9. Alright, so let's go list all of those. Originally, I'm just writing them down. I'm not doing them in any particular order. All my leaves. Alright, so I'm going to pause the video because I think this could get really boring if you watched me do this whole stem and leaf plot, and I think you probably have the idea by now. So I'm going to pause the video, and when we come back, or maybe we should make this a you try. That's what we should do. You try, finish the stem and leaf plot. Okay, now I have my stem and leaf plot, at least my initial, we'll call it a rough draft version, complete. Now the thing to do is to, for our final version of the stem and leaf plot, you want all your leaves to be in ascending order. So we're going to take our stems over here, and 7, 3, and 8. 3 and the 8 were already in numerical order. 8 leave alone. Then 9. We're going to do these in order. So I would do the 1 first. Come on, 1, no. So this is 2, 9, 1, 6. Oh, I'm sorry. Wait, that is not in order, Miss Benton. Alright, so we're going to go 1, 2, 3. 1, 2, 3. Then what would be next? 6. Then 8. Then 8. Then 9. So you want to make sure they're in order from left to right, increasing numerically. So the next one would be 3. Oh, gotta have my stem. 3, 4, 7, 7, 9, 9, 9. Okay, so again, I'm going to pause the video and I'm going to let you rearrange your stem and leaves in ascending order. Okay, whew. Now that we have our stem and leaf plot in ascending order, the last thing you want to do is title your plot and include a legend. So the title of our plot is Percent of People in Poverty . 2011 to 2012, and then we want to make a legend. Legend would be something like 7/3 means 7.3, just to show like that those numbers, that wasn't like 730 or anything like that, so that they know where the decimal point goes. The advantage of a stem and leaf plot, and I don't think I can do this on my laptop, but is that you can turn this sucker sideways, and basically this is a bar graph, guys, turned sideways. However far out this goes, that is like how tall the bar is, basically, however many you have. And so this would be what? This would be generally a skewed right distribution if you were to turn it on its side, right? Because here is the tail on the right, and here would be the peak on the left.